All right, so for chapter 6, it kind of takes a hard break from everything we were just doing with all the statistics and probability, which is where everything had been for the last, seems like 2 or 3 chapters. And 6.1 looks at systems of equations. Okay, so for those of you that were more algebra people, this is where it's going to kind of get back in your wheelhouse. If you like the stats and probability, then we're kind of leaving you out for a little bit. So this is where we'll pick up. Basically, with systems of equations, this is has 2 or more equations, and everything we're going to look at here for the first few sections is all just it's just 2 equations. So you're not going to have 3 or 4 when it comes off of this. There's 2 or more equations that's kind of basically bundled together, and when you find these, a solution must make every equation true. So they're going to give you start. They're going to start off by giving you a system of equations. Let me just show you what it would look like here. They'll do something like this. So here's your system with these 2 equations, and then they're going to ask you, okay, is 4, 5 a solution? And later on, when we start doing these, especially if we get to the parts where we have 3 equations, sometimes we'll go outside and label this just equation 1 and equation 2 just to kind of keep things straight as we're going through these. So all you have to do then is just take the 4 or 5 that you have here for your x and your y and plug that into equation 1. So that's -3 times 4 plus 5 equals -7. And basically, you just put a question mark here. Okay, so that is -12 plus 5. Does -12 plus 5 equal -7? Well, yeah, because that's -7. So that one's a yes. Okay, then we'll do the same thing with equation 2. So we're halfway there. So equation 2, we've got 4 times 4 plus 5. And again, it's basically a question mark. Does that equal 11? Well, that's 16 plus 5 equal 11. 21 equal 11. That part's a no. So if one's a yes and if any one of them ever pops up as a no, it's not a solution on this thing. So your final answer here would be no. That both equations have to be, that it has to make this equation out to be a true statement, and it has to be this equation. They both have to be true statements for that to be something that would come out to be true. Okay, so let me show you one of those just so you can see what for sure that would look like. So there's one where to ask you, is this a solution? There's what a no would look like. That if no pops up on either one of the 2 equations, it's a no. If it happened to that you plugged it into equation 2 to start with, and this one came out to be no, then you don't even have to check this part of equation 1. All right, so for example 2. Okay, there's our system. And then it's 3, 5 a solution. Okay, so take in the top equation, which we'd call equation 1. Plug in the 3, 5, and then we'll check it. So that's -18 plus 5. -13 equals -13, so that one comes out to be a check. So that one's good. And on the second equation, on the bottom there, if we check it, that one also comes out to be true. So we've got the same number equal to itself here, same number equal to itself here. So they ask, is that a solution? And in that case, that would be a yes. Okay, so pretty straightforward. They give you a point, you plug it into both equations. If either one of them is a no, it's a no. They both have to be true statements for them to be a yes. All right, and basically and you don't have to do this when we go through this one. There's 3 different ways you can solve these equations. If you were to go back and graph, basically if you went back and took this equation and rewrote it back in y equals mx plus b form and graphed it, then this thing would graph, or sorry, these 2 lines would cross at the 0.35. That's basically what it comes down to. So you'd have 2 lines that would be something like this, and those 2 lines would cross at the 0.35. And that's, sometimes they tell you can go back and check this by graphing and doing that. We're not going to do that because finding a solution for these graphing is really the worst option you can do. So the good news is you don't have to do any graphing on these kind of questions because it's the least accurate thing you can do on these to kind of get an answer for this. So that is a good news. You do not have to graph any of these. Okay, so here's the options you can do. The way we're going to do this one again, graphing is a third option you could do, but we're not going to do that just because it's the worst option to solve these. The ways that we're going to solve is we're going to look at 2 different ways. The first one is substitution. And with substitution, you've got some steps that you kind of have to go through for this one. So step 1, you're going to have to solve one equation for one variable. And it doesn't matter which variable you solve for, it doesn't matter which equation you use. It's always, it's going to work out to be the same no matter what you do. It just depends on, if you solve it one way, you may get the x value first, and then if you do it a different way, you may get the y value first. It doesn't really matter which way you go through this one. Here's kind of the way I kind of see this one. The easiest way to do this the easiest one to solve for is the variable that has 1 as the coefficient. Okay, so if you see an x that's by itself, or you see a y that's by itself, if we go back to that problem we had earlier, if we were doing this equation back here, it would be easier to solve, and really you could solve either one of these. You could solve either this one for y or this one for y because they both had a coefficient of 1. Technically, this one was -1, so this would have probably been the easier one to use back here because this would have been, this one you would just add the 6x back over here and you'd have it solved. All right, step 2 is where they call the substitution part here. You're going to substitute the equation from step 1. Into you can either say the unused or the other equation, or how you want to kind of word it here, it doesn't really matter. So you're going to take this equation you got from step 1 up here, you're going to substitute that equation from step 1 into the, we'll say, other/unused equation. And when you do that, you're only going to have one variable left. So take that equation and you solve for the variable, because you're either going to have X or you're going to have Y depending on which way you plug into it. Okay, and once you've got that variable found, again, don't get too excited and stop there. That if it's an ordered pair, you've got to have, and it should tell you in the questions when you go through these, it's going to say find the ordered pair that makes this thing solve. That step 4, then you have to take this value from step 3. That you're going to use the value that you have from this variable that you've got here in step 3 to plug into any equation to find the other variable. Okay, now just like in step 1, there's an easier part on this one that you can do. And we're going to say usually, because there's always exceptions to the rule, but pretty much any single time when you're doing this one, usually, and again, there may be one or two exceptions, but I would say 95% of the time, the easiest equation to use is usually going to be the equation that you've had in step 1. So easiest equation to use is usually the equation from step 1. Okay, now again, there may be exceptions to the rule, and there may be one that sometimes you look at it and you think it's easier to plug into a different equation, but just kind of generally speaking, that's going to be your easiest one to solve for. Okay, so let's give you some examples. We'll run through one or two of these just so you kind of see what you have here. Okay, so we've got 3x minus 5y equals 7 and negative 2x plus y equals negative 2. All right, and usually the easiest one to solve for is the one that has the variable with 1 as a coefficient. So we're going to take this equation, we're going to solve it for y. Okay, and to do that really easy, really quick, we're just going to add whatever the value is of x that's here. You're basically just going to do the opposite sign of it. This was a negative 2x, so we're just going to add 2x to both sides. So if we do that, we get y is equal to 2x minus 2. Okay, so there was our answer from step 1. We've taken, and again, you could solve any equation you want to, but if you want to avoid fractions and you want to avoid anything that may pop up and be kind of weird, if you can find one that's got a y that's here or an x that's got just the x or y by itself, then you want to do substitution. All right, somebody's probably thinking, well, what if we do an equation and neither one of them have, an x or y that's by itself? What if this thing had been 3y here, or this had been 4 or something like that? Well, then we're going to show you another option that's an easier way to do this. So substitution, you pretty much do this when you have an x or a y that's by itself. If you don't have an x or y that's by itself, the next thing we'll show you will be what your best option would be to do there. Okay, so we've taken this second equation and we've rewritten it as y equals 2x minus 2. We haven't used this thing yet, so we're going to take this and plug it into 3x minus 5y equals 7. Okay, so here's what we're doing. We're replacing y. And sometimes people get thrown off when they do the substitution on this one. So here's basically what you have. Whatever variable you get by itself, you replace y with 2x minus 2. And for some people, I don't know why it does that, but this has seemed to always work, and it's something really small, but it seems to work pretty well with people, is that if you write down that one little statement, that you're going to take out the y equals, and so just say replace y with 2x minus 2, because y and 2x minus 2 are basically interchangeable. So now down here where you have a y, you're going to take out this y and replace it with 2x minus 2. Okay, so if you ever have trouble doing the substitution, if you do that, I don't know why, but it just seems to help. I guess it's for the people that are a little bit more literal, and I know even for me it helped out to kind of. Sometimes I had trouble replacing it when I first did it, but doing something as simple as that, just rewriting it out like this, seemed to help it out. From here, you do have to do a little distributive property. And you have to be careful because the negative that's here, it's negative 5 times 2x. It's also negative 5 times negative 2. So it's going to make it a negative 10x and a positive 10. Okay. And then now you've got you got your x's over here, you've got your numbers over here. So if you've already got these x's on the same side, go ahead and do this together. So it's 3x minus 10x. Go ahead and make that negative 7x. And then we're going to move, since we've got the x's all on the same side here, let's move this 10 and move it to the right-hand side. That's negative 7x equals negative 3. Dividing both sides by negative 7, we get x is equal to 3/7. All right, now, I know most of you are going to think, okay, we got a fraction, so I did something wrong. No, you're going to get some fractions mixed in here and there. So if you get a fraction, don't freak out about it too much. That's going to pop up every now and again. If you want to go back and double check your work, if you get a fraction, that's fine. But in this case, fraction answer is okay. Okay, so now we've got x is equal to 3/7. You've got to find y. Because we're finding the final answer, kind of like the practice problems when they said, is this a solution? Well, basically now we've got half of the solution. We've got the x value. We've got to go back and find the y value to find out what this ordered pair would be. And you can plug it into any equation you want to, but probably the easiest one is back up here. Whatever we had from step 1, when we plug in this number, that's probably going to be the easiest way. So that's what we're going to do here. So we had y was equal to 2x minus 2. So we're going to use 2x minus 2. We're going to plug in 3/7 for that part. And why that usually winds up being easier is that this thing is already solved for y. So now all you've got to do is just plug in this number and do a little bit of order operations. So if we do 2 times 3/7, that makes that 6/7 minus 2. If you do 6/7 minus 2, again, depending on if you've got a good enough calculator, you can punch this in and get the answers from it. If you need to make it into common denominators, this would be 6/7 minus, if you make that a seventh, then you need to multiply by 2 to make that 14/7, because 14/7 would simplify down to 2. And then you can do 6 minus 14, which would be negative 8/7. And you can leave it like this. You don't have to make it improper. If you want to change it to negative 1/1/7, you can, but if you just want to leave it as a fraction, as long as it's in simplified form, that will be okay. So we'll take this answer, the negative 8/7, and then that would go in for the second part of it there. Okay, now of the two options, most people don't, because we'll show you the second option, because substitution, there's really not much else that you can do that's different to it. There's really no other twist. There's no other turns you can really do. I mean, there may be one little way that you can do this, but for the most part, that's pretty much about it when it comes down to it. Um, the one that most people like to use is not substitution, just because of how it's set up, and the distributed property especially kind of throws some people off, because if you miss this one sign, it throws off the whole answer, and then it kind of gets messed up in a hurry. So the one that doesn't have you require you do a little bit of distributed property here, which usually if there's one spot people get thrown off on, it's here. And sometimes it's the substitution, just because of the way the problem sets up. Sometimes the substitution part of it looks funny. Here's the way that most people would rather do a problem. I know for me, if I'm doing these systems of equations, I'm going to do this method almost every single time, unless a problem is set up exactly perfectly for substitution. I'm going to use the elimination method, just because the math is easier to me. It seems like the way it's set up, usually it's just a lot easier way to work through this one, and almost everybody prefers the elimination method after they've kind of seen what goes on with this one. All right, step one. Here's the very first thing you have to kind of have when you go through this one, and this is more procedural step than anything else. You've got to make sure that all the variables are lined up. All your variables, your equation symbols, your equal symbols, and then even your numbers that are just constants are lined up. All right, so just kind of give you a quick idea of what we're talking about here. That if you had a problem that was something like this, maybe hard to see, but let's say you had 2x plus 3y equals 4 and x equals 8 plus 5y. You'd have to go back and rearrange these, that, your x's are okay because they're lined up. You'd have to take it and you have to move the 5y over here so that you could switch these two numbers around. You'd also have to get this equal sign so that it's in the same location as this equal sign. And then the same way with your constant. So basically, you'd have to take this equation and rewrite it so you'd have x. You'd have to move this 5y on the other side of the equal sign. So you'd have something like that. So if you had an equation that was like this, you've got to have everything lined up. Your x's have to be lined up, your y's have to be lined up, your equals have to be lined up, and then your constants have to be lined up. So that's almost like just a little procedural check that you have to do if you're going to use elimination. But even that one's not bad, because all you're going to do is you're going to add and subtract some numbers from one side to the other. So, steps, as far as steps go, that one's not very complicated when it comes down to it. Okay, so you've got all your steps. Everything's lined up. We're good to go here. The second thing that you want to do is not really, I guess it's a step. And this is more like a procedure for this one, is that you want to have the same number on the same variable in both equations. And we'll do a comma, because the only difference of the two things is that you want one to be positive and you want the other one negative. Okay, so you want a 2x and you want a negative 2x. You want a 3y and a negative 3y. And again, you only need one variable. If they both work out, that's great, but really you want to key on one variable. So you want the x's to be positive and negative numbers that's the same number, or you want the y's to be a positive and negative number of the same number. It doesn't really matter which one's which, just as long as you've got one of them that's there. And the steps that you have for elimination method, they're more kind of a general steps. With substitution, it's kind of point blank. Here's, you do these things to kind of get there. This one, it's more of, well, here's your procedural step. Here's kind of what you want to do. And step 3 is more of one of those, well, if this doesn't work, then here's something else that you can do kind of thing. So basically step 3 is that if you don't have the correct numbers, if they're not where they need to be, you've got something that's off where you've got a 2x and this one's a 4x or something like that. You can multiply. Either or, in some cases, both equations. Sorry. You multiply by any number. Well, you can't use 0. That's a trick question. So you multiply by any non-zero number. Just don't use 0 because that's, making everything 0. So that's cheating. You multiply by any non-zero number to get it so that you have the correct numbers. Or we'll just say to get the numbers needed. Because even with the elimination method, there's more than one correct way to get the answers on these. So there's not one set way. There's multiple different ways you can get to an answer on these. Okay, so the first 3 steps are kind of procedural. And again, really the only thing that you're doing here is step 3, that if you need to, you can multiply some numbers out to get what you need to help with. Once you got, and this is kind of getting the setup here, once you've got all these numbers and everything's lined up, now we've got 2x and negative 2x, or we've got 3y and negative 3y. Then all you're going to do is you're going to add the systems together, or add the equations together. Okay, and the whole reason they call it elimination is that if you've got a positive and a negative, if you've got 2x and negative 2x, when you add those two together, that's going to make it 0x. If that's 0x, then that's a 0, so then that part of it's just gone. So now you've eliminated one of the variables. For the remaining, there we go, variable. So now this one, if we eliminated the x's, you're going to solve for y, so you get y equals 4, or y equals negative 2, or whatever the number is going to be. And then just like we did in substitution, here's where they're kind of the same, that once you solve for one variable, then you're going to take this answer to then plug it into any equation to find the other variable. And there is not any one easy equation to use. Like with substitution, there was always you could always go back to what we said was step 1 and use that to plug into. This one, there's no one easy one. This one, you just get to pick one. There's really not one that's easier than other. It just depends on if you want to look at it and you think this one's easier, that's the one you plug into. So there's not an easiest way on elimination. It's pretty much just whichever one you think it's going to be. Okay, so let's do this. Let me give you some examples. We'll go through like 3 different examples. We'll start with one that to me is like the easiest one, and then we'll build up to one that would be the toughest one, and then after that we'll show you a couple of special cases, and then one word problem, and then we'll be good to go. Now, and again, the setup on this one, just walking your way through it takes a while. When you actually do the work on these, it's a whole lot quicker than substitution. Okay, so for example 1, there's our system. Negative 4x plus y is equal to 2, and 4x plus 3y equals 6. Okay, and I want to give you a problem that starts off where that you've got exactly what you want. The top number is negative 4, bottom number is positive 4. So these two numbers are good to go. So we're going to go ahead and just add it together. So that's 4 plus negative 4. So that's going to be 0x, which again basically puts that at 0. So that's out. You've got, and here's where you have to be a little bit careful. Remember, if you don't have a number there in front of the y, that's a 1. So that's really 1y plus 3y. That would be 4y. And then 2 plus 6 is 8. Solving really easy. 8 divided by 4, y equals 2. And most people go, that was it? It's like, yeah, so you're halfway home. So in elimination, usually it's not always that fast, but it's a whole lot faster than doing substitution. And that's why most people like this one, because to get this first answer, usually it's almost always a little bit faster to get there. Okay, second step, we've got the y value. This is where you go back and pick any equation you want to plug in to solve for x. It doesn't matter which one's which, whether you want to plug it here or here. If you think this one's easier, we'll go with that one. So we're going to take that, plug it into this equation on top. So we're going to plug in the 2, and this one might be easier because you don't have to do anything to the y value when you plug it in. Okay, and we're going to subtract 2 from both sides, so negative 4x equals 0. You take 0 and divide it by negative 4, that means x is going to be 0 also. So final answer for that one would be 0, 2. Okay, now they're not always going to be that easy, because that's, again, just want to show you like the easiest one that's got the least amount of work to it that would kind of set up. Probably most of them are going to look something like this. All right, so for example 2, we're going to go with 3x minus y is equal to 17, and then x plus 8y is equal to 64. All right, so we don't have the correct numbers on x. We've got 3x and 1x here. We don't have the correct numbers on y because you got negative 1 and positive 8 here. So here's where that second step we said was that you can go back and multiply any equation by any number to help you get to the values that you need to have there. All right, now which one you pick, it doesn't matter because it's going to be the same either way. So if you look at this one, you can either do one of 2 options. You can either take the top row that you have, because if you multiply this by 8, you'd have negative 8 and positive 8, which would be here. You also could take, to get rid of the x's, that you could take this part of it that's here and multiply it by negative 3 to get rid of this part. So what we're going to do is we're going to take this second equation, the bottom equation that we have here, and we're going to multiply it by negative 3. All right, somebody may be saying, well, why are we doing negative 3? Well, if the top equation is already positive 3x, if we just multiplied this one by 3, this bottom equation would be 3x. And again, for this thing to work like it needs to, we need one of them to be positive and one of them to be negative. So if this one's already positive, we've got to make this one negative. So we're going to multiply everything by -3. So it's -3 times x, it's -3 times 8, and it's -3 times 64. That is -192. Okay, now I'll go back and give you a what if here in just a second. All right, so we've got 3 minus 3, which is 0. So that's what we wanted, so that the x is gone. You've got -1 minus 24, which would be -25. If we do 17 minus 192, that's going to be -175. Okay, divide those two numbers. So y comes out to be 7. Okay, so y value is 7. Again, doesn't matter where you plug it into this one, whether you go with equation 1 or equation 2. If you look at this one and you go, well, I'm not sure about the negative here, so maybe we'll take this equation. We're going to plug this into x plus 8y equals 64. So plugging in the 7, that's x plus 8 times 7 equals 64. That's x plus 56 equals 64. Subtract those two numbers, so then x equals 8. Okay, so as an ordered pair, that would put you at 8, 7. Okay, now somebody may be asking, well, what if we didn't solve for x back here? What if we had solved for y? Let me go back and kind of show you what you would have done here. If you wanted to have solved for y in this case, to eliminate the y part of it, since this was positive 8, then this would need to be a -8. It's already negative, so you could have taken the top equation and multiplied it by 8. That would have given you 24x minus 8y equals 136. Yeah, the bottom equation would have stayed the same. And then again, -8 plus 8, we eliminated that out to be 0, so that would have been gone. That would have made that 25x and 200. Divide those two, and you would have gotten the x equals 8. Okay, so it doesn't matter which one you solve for. You should get, no matter which one you do, as long as you do the math correctly, you'll get the correct answer. One time you may get the y value first, one time you may get the x value first. Which one you get first, it does not matter, just as long as you get both of them. And just remember that when you plug it back into ordered pair form, it's always the x values first and the y values second. Okay, so here's example 3. This is the worst case scenario. Okay, so we've got 3x plus 2y equals -1, and then 5x minus 3y equals 11. All right, here's what makes this one a worst case scenario. There's not a number you can multiply, because you're always going to take the smaller number to try to multiply it by something to get the bigger number. There's nothing you can multiply to get from 3 to 5. If you did 3 times 2, you can make it 6, but that's not going to work. Same thing here. To get from 2 to 3, there's nothing you could use. Now, you could use a fraction or decimals, but nobody wants to do that because that's no fun, because nobody likes fractions or decimals. So there's not any one way to multiply one equation by one number to get from this equation, to get from this number to this number. You'd have to use fractions or decimals. If that's the case, then what you have to do is basically just pick whether you want to get rid of the x's or the y's. And if I'm doing one like this one, I always try to pick the one that's got the signs already changed. because the less times you have to decide, because this case you got both of them are positive, so you'd have to make, if you keep this one positive, then eventually you've got to make this one a negative. Or if you made this one negative, then you have to make this one positive. So if you have one of these that the signs are already different, I would say kind of stick with those two numbers. And here's what you're going to do. Since this is 2 and 3, the first number they have in common, the first common multiple would be 6. So what we're going to do is we're going to take everything in this equation and we're going to multiply by 3 to make it 6. We're going to take everything in this equation, we're going to multiply by 2, so this would also be 6. So then if we do that, that'll make that a positive 6. This will be a negative 6, and then we can add those two equations together and find the numbers that we need. And somebody may be saying, so we're basically just flip-flopping these two numbers. Yes, so we're going to take this number, move it up here, and multiply this equation by this number. We're going to use this number to then multiply this equation by this number, so we basically got the same answer here. Now, some people like to, instead of doing that, some people would rather just take these two numbers and say, all right, well, let's just flip these two. I can multiply this by 5 and this by 3, and I've got 15 and 15, which is okay. You can do that one too. So whether you pick the X's or the Y's, it doesn't matter. If you do this one, if this one's positive, this one's going to have to be negative, so you're going to have to multiply by negative 3. So again, that's your choice. It doesn't matter whether you solve for X or whether you solve for Y first. So you can do either variable to kind of get there. Okay, but I'm going to pick this one because the signs are already different and these numbers are smaller too. So that sometimes people like that because they'll pick the smaller numbers. Either way you go, it doesn't really matter. All right, so multiplying everything by 3. That'll make that 9x plus 6y equals negative 3. This will be 10x minus 6y equals 22. Okay, and then put it all together. So we've got 9 plus 10 for 19. That'll go to 0. 22 minus 3 is also 19, so that gives us an x value of 1. Okay, and again, pick any equation you want to plug it into. I'm going to say for this one, let's go into 3x plus 2y equals negative 1. So it's going to be 3 times 1 plus 2y equals negative 1. That's 3 plus 2y equals negative 1. We're going to subtract and run out of room here at the bottom of it. So we're going to subtract 3 from both sides. That's going to make it to be 2y equals negative 4. And then dividing by 2, we get y is equal to negative 2. So x value is 1, y value is negative 2. Okay, so same setup, just difference is in this case, again, that there's nothing you can multiply to go from the smaller number to the bigger number. So in that case, you're going to have to multiply both equations by some number to kind of help out there. Now, most of them, you're probably not going to have a lot of these. You might have one of these that will sneak in. Most of the problems are going to probably be more like number 2, that you're going to have to multiply one equation by one of the variables or one constant to help you get through that one. Okay, and here's your trick cases, your special cases, special problems, trick case, whatever you want to call them here. Basically, when you do the math and you get to the end, you go, wait a minute, that's not what I thought it was going to be. Okay, so we've got 2x plus 3y is equal to 4, and then 4x plus 6y is equal to 8. All right, so this is one most people go, all right, so I can get from 2 to 4 by multiplying this equation by -2. So I'm just going to take this top equation and multiply by -2. Okay, so if we do that, we get -4x, -6y equals -8. Bottom row, we get 4x plus 6y is equal to 8. Add those together, that's a 0x, so that's out. We get 0y, that's also out. And then you go, wait a minute, you get that. So if they both go away, you've got 0x plus 0y. Basically, that's 0 plus 0. So basically, you do get 0 plus 0. All right, so here's the special case in this one. Both variables are gone. If you get to the end and you get 0 equals 0, this is always true. So what they're going to ask you is that they're going to give you an option. They're going to say, well, if it's always true, no matter what happens here, then this is where you're going to have infinitely many solutions. That basically what you have is you've got the same line on top of itself. So if we were to graph this one, and it was a line that looked something like this, if you graph the second line, it would be the exact same line in the exact same location. It's just written a different way. It's 6 of one and half a dozen of another. Well, it's the same thing, right? Okay, so if you get to the end and both variables are gone and it equals 0, then that's going to be always true. Here's the other case. Here's the other special case you get on this one. Let's go with -3x plus 6y equals 10, and then x minus 2y equals 5. Okay, so we've got -2 to get to 6. We're going to multiply by 3. Or again, you've got a 1 here, so we're going to multiply this equation by 3 to get everything lined up to be what we need it to be. Okay, for this one, we'll do the same thing. We're going to add these two equations together. You get 0x, you get 0y, which again basically means this side goes out to be 0. But on this side, you get 10 plus 15 equals 25. If this doesn't make any sense, then that means it has no solution. That basically in that case, you have two lines that are parallel, so they're never going to cross. And if they're never going to cross, then it's just not possible. Parallel line. There we go. Okay, so that's your two special cases that may pop up every now and again when you go through these. So basically, the special case is that both variables go to 0. If the second number is 0, it's going to be infinitely many solutions. It's the same line on top of itself. If this second number on the right side over here is something other than 0, then it's going to be no solution. And that's your two trick questions that you run across. Okay, one last question, and then we're done. And this is kind of a word problem type thing. A 6,000 seat stadium has two different ticket prices. One's $26 and the other one is $40. How many of each needs to be sold to create revenue of $188,200. Sorry. Gotta go ahead and move down to the next page here. Okay, so here's what we've got to do. You've got now. Here's the part. Sometimes people kind of skip over the first one because they'll figure some things out and get the second part. The one that's sometimes the easiest to look past is it's a 6,000 seat stadium. So you've got two different types of tickets. You can call one of them X and one of them Y. X is the $26 tickets and Y is the $40 tickets. You know, or whatever you want to call it, doesn't really matter. The one thing that sometimes people miss is they're like, okay, well, I've got to have 26 of these, I got to have 40 of these, and this is got to come out to be this. Sometimes people kind of skip over this number. If it's a 6,000 seat stadium, then when you add all the tickets together, that's going to be 6,000. So basically, this is like your tickets. And now you're going to talk about the money. Well, each X ticket is $26. Each Y ticket is $40. And that's going to come out to be $188,200. So sometimes people will get that one easier. Sometimes they're like, what's the second equation? Because I don't know, what our numbers are. So if they tell you what the capacity is, that's kind of your number you have to use there. Okay, and then from there, you can either do substitution or you can do elimination. Again, most people probably will go with elimination. I mean, it just seems to work out a little bit easier. I'm going to pick the smaller number, which is the 26, or maybe you go, well, I'd rather multiply by 40 because it's easier because of the 4 ending in the 0. Doesn't really matter which one you pick here. Let's just take this top equation and multiply by negative 40 because this one's already positive 40. So we need to make this one a negative 40. So we're going to multiply this one so the 40s will cancel out. Okay, so that's going to get us negative 40x minus 40y equals negative 240,000. The bottom one didn't change. Okay, we're just going to put these two together so that now the y's cancel out and then it's gone. We've got negative 40 plus 26. That's going to be negative 14x. People start to get worried because like, well, how's this going to be? You can't have a negative tickets. Well, when you subtract these two, that's going to take care of it because that's going to be a negative number when you get there. It's going to be negative 51,800. Okay, we're going to divide those two numbers. And x comes out to be 3,700. Okay, and of the two, I think this is definitely going to be the easiest one to plug into back up here because there's 6,000 seats total. There's 3,700 of the X seats. So then to get the Y seats, we just need to do 6,000 minus the 3,700. So that then comes out to be that there's 2,300 of the Y seats. Now, this may be one of those where they'll probably ask you, tell me how many are the $26 tickets. So we said that X was the $26 tickets. So there's 3,700 of the $6 tickets. And then there's 2,300 of the $40 tickets. Okay, and again, it doesn't matter which one you let be X and which one you let be Y, as long as you know which one's the $26 tickets and which one's the $40 tickets. That's really all that you have to have. So. Okay, so that was it. That's it for section 1. And we're not going to do anything else with section 2 or 3. We'll wait and get that another day. Just had to get this one section in to kind of keep us on track where we need to be for the next couple weeks coming up. So really right now, just focus on the chapter 10 test because it is due. I believe it's due tomorrow night. So you've got tonight and tomorrow night to kind of check up on that one. So if any questions about anything at all. Oh, sorry, Jasmine, go ahead.
Number 6 on 10.1,
Mm-hmm.
I was kind of confused about.
Okay. All right. Let me take a look at that real quick.